Dear students, in the previous class I have discussed about the very fundamental concept of classical mechanics, that is force. And here in this class I will discuss about the trajectory of motion of the particle. And the trajectory of motion of the particle will completely depend on the direction of force. In which direction the particle will go, it will completely depend on in which direction we will give the force. That is, here we will consider the direction of force with respect to velocity. That is, here we will discuss actually the trajectory of motion with respect to the angle between F and V. And there are three possible cases depending on the angle between the force, application of force and the velocity factor V. And the very first one is when theta is equal to 0 or 180 degree. That is the force is acting along the motion or opposite to the motion. If the force is acting along the motion, that is when F is parallel to V, then the magnitude of the velocity will increase, but the direction will not change. So the particle will follow the same path, that is the straight line path. Similarly, if we give the force opposite to its velocity, that is when F is anti-parallel to V, then the velocity of the particle will decrease, but the direction of motion will not change, and that's why it will follow the same path, that is straight line path. So for the first case, when theta is equal to 0 or 180 degree, the trajectory of particle will be straight line. But if we give the force perpendicular to its motion, that is perpendicular to its velocity, then it will follow the circular path. And at each and every point, if we consider the force is in inward direction and the velocity is along the tangent, so the angle between F and V is always 90 degree, that is perpendicular to its velocity. And this is the condition that the particle will move along a circle. So this is actually, we will discuss in circular motion, that this is actually the centripetal force that is necessary to hold the particle in this circular path. So we can say that when F is perpendicular to V, then the particle will move along the circular path. So we can see particle will move along circle. So here the trajectory of motion or the locus of the particle is circle. But when theta not equal to 0, not equal to 180 degree or not equal to 90 degree, that is no special case, that is a general case. When theta can take any value other than this, because we have already discussed in two cases for these values, that is 0 or 180 and 90 degree. So for general value of theta, what will be the path? So here let me consider the particle at any instant of time. The particle has a velocity v like this, and a force is acting at an angle theta with the velocity. So what will be the component of the force? This force has two components. One is along the velocity, that is f cos theta, and another is perpendicular to this velocity, that is f sin theta. Now if we look carefully, that this f cos theta is now parallel to v, and this case we have discussed here, that f is parallel to v. Here the role that plays this f, the same role plays here f cos theta. Here f cos theta is parallel to v, whereas here f is parallel to v. This f is parallel to v. So this f cos theta component will try to move the particle along this straight line. But this f sin theta, it is perpendicular to v. That is here for circular motion, f is perpendicular to v. So this f sin theta is perpendicular to v. That will play the same role as here play the f. So this f sin theta will try to move this particle along circular path, but this f cos theta will try to move the particle along straight line. So here the motion of the particle will be complicated, and is actually the combination of these two motion, that is linear motion as well as circular motion. So the combination of two motion will be helical, because when f sin theta try to move it in the circular path, then f cos theta try to move in this direction, that is the straight line path. So the particle will move due to f sin theta, circular path want to move along this, for this f sin theta along circular path, but due to this f cos theta it will follow this helical path. Okay, so this is the general case when theta not equal to 0 degree, 180 degree or 90 degree. Okay, so the particle will follow helical path. So these are the possible trajectory of the particle depending upon the angle between F and V. But please remember that here the only force F is acting. No other force is involving here, even if the gravity is also present, not present here. Okay, we will consider this as a point particle. So the gravity is also not here. because this mg force will be very small. Not only this, other than this force F, there is no other force. This is only for the applied force F, and this applied force F is acting on the particle at each and every instant of time, and in that case this trajectory will, the particle will follow this trajectory. Okay, thank you.